minus 0.031 A is equal to 0.04 A. And then you will get 25 A. So you can use your calculator to calculate to see if you can get the same number. And then finally you can get A is equal to 4.29. So the correct answer will be C.
Okay, just explain how you did the calculations.
Yeah.
Just explain that part. I understand it. I just want to see how you got that and that. Where did that come from?
So I can do it for you. So here, if you expand, right, that will be 0.5 times 9.8 will be 4.9, right?
Mm-hmm.
Here, times 25
okay. So
minus, if you just need to expand.
So you're foiling.
Yeah. 0.5 times 25A, right?
Okay.
And then here is 0.04 over 0.25. Actually, if you calculate, here will be 0.16A. Okay?
Because it's 0.04 over 0.25?
Yeah.
Okay.
So, and then you move this to this side.
And you divide.
4. You can use a calculator. So it will be 0.16 plus 0.125A. So you move all the A together, right? Is equal to here. Will be 4.9 divided by 4, actually. 1.225. So it's 1.225. So here is 0.285A equal to 1.225. Let me calculate it. You understand so far?
Yeah, because you just did here minus that, and you could have bought point.
I move here to this side because you have A and A, right? You want to move those factors
Move that over that
at the
side,
same,
and then
yeah.
you divide it.
And then here you only have a number, so you divide, right?
Yeah, you divide. Okay.
1.225 divided by 4.3.
Okay.
If you calculate. Okay. That's number 6. Then number 7. It's kind of similar. Just incorporate this circular movement with what we learned before. Something. This is 4 kilograms. Okay, and that is 6 kilograms. Smooth horizontal surface. The pulley rotates. The radius is 0.12. The moment of inertia is 0.09. So the acceleration. Remember, for this kind of question, they ask you the acceleration of this m. the acceleration for this big M will be the same because they are connected to each other, right? If the acceleration for this, is, for example, is 5 meters per second square, this one should be the same. So that's one thing you need to remember. And here, the tangent acceleration will also be the same. Okay. So let's say here we have a tension T1, and here we have tension T2. Okay. It will be different because right now we are considering the moment of inertia for the pulley. Remember before when we consider the pulley, there's nothing like there's no energy there. So we need to analyze this one. Oh, sorry, let me put T1 here and T2 here. So for this object, it's moving towards this side, right? There's only one force on this x-axis, and T1 is equal to times the acceleration, right? So that's the first one. And then the second one, we analyze this small object. It will be T2 and then mg, right? So mg minus T2 will be ma. Remember this A and this A is the same thing. Okay, so we got 2, and then we analyze this pulley. So there are two tangent force. One is T1, here is T2, right? Along the pulley. So, but this one will be bigger because you know it's rolling this way. So we have torque 2 minus torque